Let's see if you can answer this question. How fast does light travel? The answer, 300 million meters per second. Let's say you're driving down the road at 30 miles per hour, and then you throw a ball that goes 20 miles per hour in your perspective. How fast does the ball actually go? Use this formula to calculate the speed of the ball. If you solve the equation, the answer would be the ball goes 50 miles per hour. Newton's laws of motion. This blue guy is going to kick the ball. As you can see, he's acting a force on that ball. Isaac Newton also made another equation. F equals m times a. It means that the force pushed by that ball is equal to the mass of that ball times the acceleration of that ball. Here is a definition of speed. We will test this equation out later in the video. Let's test this equation out. The car drove 10 meters and it took 5 seconds to drive that. That means the car drove 2 meters every second. Now, a car is going to bump into a tree. And then you're going to notice how it bounces back. That is another law that Newton made. Also, if two objects crash into each other, they're going to collide and go apart. Isaac Newton also made theories about gravity. You also probably heard about the story where an apple dropped on Isaac Newton. One month later, this is an example of gravity. It's a ball bouncing. In gravity, objects fall faster and faster until they hit the ground. For bigger objects, the gravitational pull is stronger. They are heavier. He also figured out how orbiting works. Copernicus and Galileo were the first people to take advantage of this idea. At the time, most people thought the sun orbits around the Earth, when the real answer was the Earth orbits around the sun, proposed by Galileo and Copernicus. Newton also made another equation to determine the force of gravity between two objects. The gravitational force of Jupiter and Saturn is equal to the gravitational constant times the mass of Jupiter times the mass of Saturn divided by the distance squared. Newton made another equation saying energy transferred is equal to the mass times the distance. Let's test this out. The ball and the shoe are both accelerating together. The force is 1 Newton and the distance is 1 meter. That means the energy is 1 meter Newton. In 1687, Isaac Newton published his book called Principia. This is what is included in the book Principia. We are going to learn about waves and sound. Now we're going to start talking about sound waves. As you can see, this is a sound wave. It is moving from left to right. The distance from the top to the bottom of the wave is the amplitude. The distance between each peak of the wave is the wavelength. The lower the amplitude, the softer the sound will be. The higher the wavelength is, the higher pitch will be. That concludes the video.